In this video, I'm going to show you how to solve rational equations. And the step we're going to do is similar to before, but this time our LCD, lowest common denominator, is going to involve variables. So we're going to find the lowest common denominator, and then we're going to multiply each term by the lowest common denominator. Then we're going to solve for the unknown. So let me start you out here with an example. Let's say that we have x plus 12 over x equals negative 7, and since we can think of x as x over 1 and negative 7 can be thought of as negative 7 over 1, then the only denominator we have other than 1 is x. So my least common denominator must be x. And also note that x can't be 0, because if you had 12 over 0, that would be undefined. Okay, now, so what I'm going to do is, to get rid of my x here in the denominator, I'm going to multiply 12 over x by x. But if I do that, I have to multiply every term by x. So I'll have to multiply x by x. And of course, when I do that, that'll give me x squared. And then when I multiply x by 12 over x, then the x's cancel, and I just get 12. And then when you multiply negative 7 by x, we get negative 7x. Okay, now this equation, we're going to learn more about these types of equations later, but right now this is actually a quadratic equation. And so what I want to do with these types of equations is I want to get the negative 7x to the other side. So you can either add 7x to both sides, or you can just say I'm going to move the negative 7x over here and change its sign. But either way, you're going to end up with 0 on the right when you get rid of the negative 7x, and you'll have plus 7x on the left. So we have x squared plus 7x plus 12. Now, you really, to solve this, you just need to factor this, and this is really not difficult to factor. You just have to find two binomials that multiply together to give you this trinomial, and you can see that I got x plus 4 and x plus 3. And then to solve this, you actually just set those equal to 0. So if I set x plus 4 equal to 0 and solve that equation, I get x equal negative 4. And then if I set x plus 3 equal to 0 and solve that one, then I'll get x equals to negative 3. So your two solutions would be negative 4 and negative 3. But make sure you always check and make sure that those are in the domain, because you know, if x, see here I said x can't be 0, but maybe in another problem x can't be negative 4. And so if x couldn't be negative 4, then you couldn't use the negative 4 as one of your answers. But both of these answers work, so the answers are negative 4 and negative 3 for the answers. Okay, now the next one is a little more complicated. So let me just show you here. Okay, so there's the problem. So I have 2x over x squared minus 4 plus 1 over x minus 2 equals 2 over x plus 2. Now, if you factor this denominator, you can actually see that it factors into, whoops, wrong one. You can actually see that it actually factors into x plus 2 and x minus 2. So if you rewrite this, you'll see that the denominator of the first term is just x plus 2 times x minus 2. And now, so that means that I just need a factor. I need some sort of a denominator, lowest common denominator, that all three of these will go into. Well, why don't I just use x plus 2 times x minus 2 for my lowest common denominator? Because then I know that, obviously I know x minus 2 will divide into this. I know x plus 2 will divide into this. And I also know x plus 2 times x minus 2 will divide into this. Okay, so I'm going to use that for my LCD. So now, to eliminate fractions, I multiply each term by this. So multiply on the right-hand side of this fraction. Actually, I'm on the left side of the equal sign, but the right-hand side of this fraction. So I'm going to take this x plus 2 times x minus 2, and I'm going to multiply it by this fraction here. And then when I do that, then both factors, the x plus 2's cancel and the x minus 2's cancel, and I just get the 2x. So I just get 2x there. Now when I multiply this fraction by x plus 2 times x minus 2, the x minus 2's cancel, and so I end up with 1 times x plus 2, and 1 times x plus 2 is just x plus 2. And then on the right hand side, if I multiply the 2 over x plus 2 by x plus 2 times x minus 2, the x plus 2's will cancel, and I'll get 2 times x minus 2. Okay, now if I sum 2x and x over here, I'll get 3x plus 2 on the left. And then if I multiply 2 times x minus 2, I'll get 2 times x times 2 times negative 2, so I'll get 2x minus 4. Now here, I probably should have showed you some more steps here, but what I'm going to do here is I'm simply going to subtract 2 from both sides, and that'll give me just 3x. That'll give me 3x on the left, and then it'll give me 2x equals negative 6 on the right. So, 2x minus 6 on the right. So, hang on. So it'll give me 3x on the left, and it'll give me 2x minus 6 on the right. That's what I meant to say. Okay, now just subtract 2x from both sides. So subtract 2x from both sides, and you'll get x. So on the left hand side you'll get x, and on the right hand side the two x's will cancel, and you'll get negative 6. So your answer is negative 6. And remember, x can't be 2 or negative 2 because it would have made those denominators 0. But I did not get 2 or negative 2. I got negative 6. So that answer does work. Okay, so the next one here, I have 22 over 2p squared minus 9p minus 5, and then minus 3 over 2p plus 1 equals 2 over p minus 5. Okay, well, another way to write that, actually the first term will factor. The first term actually factors into 2p plus 1 and p minus 5. And luckily that's what these are, 2p plus 1 and p minus 5. So I can just let my least common denominator be 2p plus 1 times p minus 5. Now, should say p cannot equal. So p cannot equal negative 1/2, because if it does, it gives you a 0 in this denominator. And p cannot equal 5, because if it does, it gives you a 0 in this denominator. So keep that in mind. Okay, now, so I'm going to multiply this term here by the LCD, and then both the 2p plus 1 and the p minus 5s will cancel, so I'll just get 22 here. And then here, if I multiply minus 3 over 2p plus 1 by that, the 2p plus 1's cancel, and I just get the minus 3 times p minus 5. And then if I multiply 2 over p minus 5 times the lowest common denominator, the p minus 5's cancel, and I get the 2 times 2p plus 1. Now let's clean up the left-hand side. If you distribute the minus 3, you get minus 3p plus 15. So I get 22 minus 3p plus 15. And if I distribute on the right-hand side, 2 times 2p would be 4p, and 2 times 1 would be 2. And now what I'm going to do first here is I'm going to subtract, I'm going to add 22 plus 15, because they'll combine. So 22 plus 15 is 37. So I get minus 3p plus 37 equal 4p plus 2. And let me show you those steps here. Just hang on just a second. So here's where I was. Minus 3p plus 37 equals 4p plus 2. Now to get rid of the 37, all I'm going to do is I'm going to subtract 37 from both sides. So that will cancel this 37. So subtract 37, and it's going to cancel this 37, and I'll just get minus 3p. And then on the right hand side, I'm going to have 4p plus 2 minus 37, and 2 minus 37 gives me a minus 35. So on the right hand side, I still have the 4p and the minus 35. Now to get all the p's on the same side, I'm going to subtract 4p from both sides. So on the right hand side, if I subtract 4p, the 4p minus 4p cancels, and I just get the minus 35. But on the left hand side, I'm going to have minus 3p minus 4p, which is minus 7p. So I end up with minus 7p equals negative 35. And then the last step, I think you can probably do in your head, just divide both sides by negative 7, and you'll get p equals positive 5. But remember, p can't equal 5. That's not in the domain. So therefore, we have no solution, because p equal 5 was our only answer, and that's not in the domain. Now, a special type of rational equation is a proportion, and a proportion is when you have a single fraction on each side. So here I've got a single fraction on the left, and I have a single fraction here on the right as well. So you can see there I have a single fraction on each side. Now, but what you can do, you could solve this the way I solved those others, but what might be quicker is to do something that's called cross multiplying. So let's take a look at that. If I cross multiply, it just means that I'm going to take multiply from the numerator on one side to the denominator on the other side. So I'll take x minus 3 and multiply it by x, and then I'll multiply from the denominator on the left side to the numerator on the right side, and that'll give me 5 times 8. Now this only works when you've got a single fraction on both sides of the equal sign. If you have two fractions on one side or the other, like I had on the previous problems, you can't solve it this way. Okay, now x minus 3 times x is x squared minus 3x, and then 5 times 8 is 40. So I get x squared minus 3x equals 40. Then if you move the 40 on the other side, you can change its sign, and you get x squared minus 3x minus 40 equals 0. Then we can solve this by factoring, because this factors into x minus 8 times x plus 5, and it would equal 0. And then x minus 8 would equal 0, or x plus 5 would equal 0. And then to solve that, if you add 8 to both sides here, you get x equal 8. And if you subtract 5 from both sides here, you get x equals negative 5. Okay. Now the other one's a little bit nastier, but if you just multiply x squared times x minus 4, and then 16 times x minus 4, and then over here you can distribute, and you get x cubed minus 4x squared, and over here you distribute, you get 16x minus 64. Move all the terms over to the other side, and then you'll get x cubed minus x squared minus 16x plus 64 equals 0. And you may remember how you factor by grouping. So in these first two terms, I can factor an x squared out, and I get x squared times x minus 4. And the second two terms, I can factor negative 16 out, and I get negative 16 times x minus 4. Then, since I have a common factor of x minus 4 here and x minus 4 here, I can factor it out, and then I'm left with this x squared and the minus 16 on the inside. Well, then that will factor into x plus 4 times x minus 4. So I end up with 3 factors, but two of them are the same. So I end up with x minus 4 times x plus 4 times x minus 4 equal to 0. So if you set x minus 4 equal to 0, you get x equal 4. And if you set x plus 4 equals 0, you get x equal negative 4. Okay, but remember, up here, x cannot equal 4, right? So we have to throw this one away, and so our only answer that works is x equal negative 4. And so that's how you solve rational equations. And I'll do some applications of rational equations in the next video.